chapter 3, section 2. We're talking about the mean value theorem, and we'll discuss that a little bit later. But first, we're going to talk about the Rolle's theorem. So with both of these theorems, we have to satisfy the conditions. All right, so here's the mathematical speak here about Rolle's theorem, and f is just some function, and it has to satisfy this condition. So it has to be continuous on its interval. Okay, so however far you're going, first x, second x, right? This is not a point, this is an x value, and this is an x value. So as long as it's continuous in there, right, has no holes, has no jumps, or then we're good, right? And f also has to be differentiable on a to b, meaning that you can find the derivative anywhere between those two x values. And then third thing is f of a has to equal f of b. Okay, so that means your y values, when you plug in these x's into your original f equation, your y values will be the same. Okay, so you have to meet those three conditions. This one, whenever you have a polynomial, you can say it's continuous, right? Because I can plug anything into the domain and get an answer out. So it's going to be continuous. And then differentiable, all polynomials, you can take the derivative of it, right? And you can plug in a number and solve for that as well. And then just this is the key usually. Okay, if you have a fraction like x minus 3, then you just have to make sure your a and b don't make the denominator 0. If you have a square root function, just make sure when you plug in this you don't get a negative square root in between here, and then you're good. But if you have a polynomial, these first two conditions are pretty much satisfied. You can say because it's a polynomial, it's continuous and differentiable. I'm okay with that. But you do have to do this third part, right, with all your functions that you're giving. Okay, so if those three conditions are met, then there has to be some x value between these a and b, such that when you plug in that x into the derivative, you get 0. Okay, so there's some x between these two x's of a and b that when you plug that into the derivative, you get 0 as an answer. Okay, so that's what Rolle's theorem says. So it might look something like this. So here's your function f, but we are on a closed interval, right? So here's my a and here's my b. So here's my a, so that's what I'm limiting my function to. So this doesn't keep going, and this doesn't keep going. So you notice that it's a continuous function. There's no holes or jumps, right? And that it is differentiable. I can find the derivative, right? There's no vertical asymptotes. So that means that I can find the derivative of each of these points. And then so what I'm looking for is, I'm looking for my f of a to equal f of b, meaning when I plug in my a, oops, I erased it. When I plug in my a and I plug in my b, I get 0 as answers into the original. Or not 0, sorry. But I get the same answer. So both of these get 0 as an answer. So f of a equals f of b. Now, Rolle's theorem says, now we can use it, Rolle's theorem says there has to exist some x values between -1 and 3 that when I plug those into the derivative, I get 0, right? Which would be where my horizontal, tangent of the horizontal, right? Or my tangent line is horizontal, right? Where my slope is 0. So that'd be at 1. That'd be right here, wherever this x value is. I said 2.3. I just estimated there. Okay, so it's wherever you have those hills and valleys. Okay, so it's the same thing pretty much as what we've been doing. It's just this theorem says that as long as it's continuous, as long as it's differentiable, and as long as our two x values have the same y value, then there has to exist some x value that we're going to have a hill somewhere or a valley somewhere between those two numbers. All right, so how is this applied? We have this function, sine of x. So remember, sine of x does go on forever, so we need an interval, right? 0 to 2 pi. So we could go ahead and graph this. We don't have to graph it, but here's what the graph looks like. So the things that we must do is we must check to see if it's continuous and differentiable. Well, sine, I can take the derivative of sine, right? It keeps on going. There's no vertical asymptotes. We know it's continuous, so it meets conditions 1 and 2. So I would just say that its sine function is continuous and differentiable, meets the first two conditions. Now I have to prove f of a equals f of b. Okay, so how I do that So I label my A here, and this would be my B. So I take f of A, which would be plugging in A in for my x, or 0, sorry, because my A is 0. So f of 0. And then setting that equal to, and proving that it equals, really, sine of my B, which is 2 pi, which we know these are true because they both get 0. So that's step number 1, complete. Check that off. Okay, now we derive the function. And we go ahead and set that function equal to 0. So that is cosine of x. And now we set it equal to 0, step 3. And then we go ahead and solve for x. So what x value, what angle do I get 0 at from our interval 0 to 2 pi? So cosine is 0 at 90 degrees, or pi halves. Since we're on a 0 to 2 pi, we just use radians. And it's also at 3 pi halves. That's where it's 0. Okay? So those would be my answers, and then I just switch x to c, because that's the definition of there's some x value c such that blah, 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 blah. So we just switch it to c. Okay, so those are my two values that give me, when I plug those into the derivative, I get 0. All right, so here's another example. Again, this is a polynomial. Okay, so it's polynomial, continuous, and differentiable. Okay, so you have to state that, and then you have to prove that f of a equals f of b. So f of 1 equals f of b. So I plug those in. All right, so I get 5 minus 12 plus 3. Is that equal to 5 minus 12 times 3 plus 3 squared, then times 3. So I'm plugging in my a and I'm plugging my b and see if they come the same thing. All right, so this is 27 minus 36 plus 5, so that's negative 9 plus 5 is negative 4. And so we're going to see if this is true. All right, this is 8. 8 minus 12 is negative 4. Negative 4 equals negative 4. So now we can go ahead and use Rolle's theorem. So all three conditions are satisfied. So f of a equals f of b. Then, right, so I would meet the first conditions. This would be condition number 1 and 2. This is condition 3. Then Rolle's theorem applies. Rolle's theorem applies. So then I can say there's some value c, so there's going to be some value c such that f prime of c equals 0. So I use that fact. Now I can apply this, and I can take this equation, and I can take the derivative of it, and then I can go ahead and set that equal to 0. So there's some c value that equals 0. So if you want to change x to c right now, you can, but it doesn't really matter. So I'm going to set it equal to 0. Okay, and then I'm going to solve for x. So x equals 2 or c equals 2. Okay, so that's the value that makes my derivative equal 0. So what that tells me is there's some, at 2, my graph has a hill or a valley at 2. So either it's a hill, right, something like that, or it's a valley, something like that. Okay, and we use this for graphing later on. And we've already been doing this, setting our derivative equal to 0 and solving for x. So it's something that's not really new. All right, so the main theorem, what Rolle's theorem leads us to, is this thing called the mean value theorem. And so again, we have this function f. It has to meet these conditions first, so it's kind of the same thing a little bit as Rolle's theorem. It has to be continuous on an interval and has to be differentiable on that same interval. Okay, and all I have to do is meet those two conditions. Okay, so my f of a doesn't have to equal b. So mean value theorem, it doesn't have to equal that. So if that's true, that means that f prime of c will equal my slope. right? Isn't this my y value when I plug in b? Isn't this just my y value when I plug in a? So that's just y2 minus y1. And isn't b just my x value? And isn't a my x value? So isn't this just the slope? So that's all that it's saying. It's saying if it's continuous and it's differentiable on the interval, then somewhere my slope will equal, and what is this? It will equal the slope of between the x and a value. So that's what this is saying. My derivative will equal the slope between a and b. So this is my slope between a and b. So if I have 2 points, if I have an a, maybe a different color, if I have an a and I have a point, a f of a, and I have another x value b, and this will be f of b. So I have this point b comma f of b, and this point a comma f of a. I could take the slope between these 2 points, right? Well, what this is saying that there has to exist some value c, that if I take this value of c, then I can use that value of c and its y value, f of c. I can use that y value, and I can go ahead and write the equation for a tangent line, and that equation for a tangent line at that c value will be the same line. It'll have the same slope. It'll have the same slope between the points a and b. So it'll have the same slope. So hopefully that makes sense. So if you have 2 points on an open interval, the function is continuous. Okay. Then the slope between these 2 points, mean value theorem says there has to exist some c value that you can write the equation of the tangent line on that c value, and it will have the same slope as those 2 points. That's what it's saying. So here's the steps, and here's an example. So again, you have to meet the conditions in order to use the theorem. So I have to prove this, and most polynomials that you have, you can just say it's a polynomial, so it's differentiable and continuous. Okay, but those for mean value theorem, those are the only 2 that I need to do in order to use the theorem. Okay, so now I just go ahead and find the slope between the 2 points. So find f of a and f of b. So I plug in my f of a, and I solve that, and I plug in my f of b. I'm getting those from right here, a and b. So I plug that in, 2 cubed minus 2. That's just 6. So I get 0 and 6, and then I take the difference of those. So 6 minus 0 divided by, find the slope, 2 minus 0. So that is 6 over 2, which is 3. So the slope, this thing, equals 3. Or you can just say m equals 3. It's okay. Okay, and now I'm going to derive my function. So it's x cubed minus x. So here's my function, x cubed minus x. Derive that. 3x squared minus 1. Okay, and then I'm going to set that equal to, those look like the same steps, set equal to the slope of a and b. So I'm going to set this equal to my slope, 3. And then I'm just going to solve this quadratic equation. And this one I don't have a b, so I'm just going to add 1 to both sides and divide by 3. I didn't mean to write a 3 there. So x squared equals 4/3, so I need to square root both sides. So that equals plus or minus 2 over root 3. Because square root of 4 is 2, and I just square root the bottom 3. So I just need to make sure those are on my interval, and my interval is from 0 to 2, so the negative's outside my interval. So c would just equal 2 over root 3. okay, because the -1 is outside my interval. All right, so you want to use those steps, go ahead. So make sure you prove the first conditions. Rolle's theorem, you have to prove 3, and mean value theorem, you only have to prove the 2, continuous and differentiable. And then again, we're doing the same thing as we've been doing for the last couple chapters, is taking the derivative, and then this time we're just setting it equal to 0. But on mean value theorem, we set it equal to our slope between the 2 points. Okay.